we're going to take a look at circles and make sure you have your conic sections flip book with you. Alright, under your important information tab, we're going to do just a couple vocab words for this one. And the first one is circle, and it's the set of all points x and y that are equal distance from a fixed point called the center. Then our other one is the radius, and that's the distance from the center to any point on the circle. Alright, we only have one form for an equation for circles, and it is x minus h squared plus y minus k squared equals r squared. Now the reason we don't have to worry about a second form is because even if I flip these around and put my y minus k squared first, since it's addition, we have the commutative property, which means the order doesn't matter, so it would essentially be the exact same thing. And then the other part is that both quantities are squared, so there's no difference there. On the back side of the flap for your equation, we're going to do a very simple picture for that one, and draw yourself a circle and put your center point in there. Notice again we have h and k, so our center point is h comma k. And then our value here, the r squared, well, that represents the radius squared. This point right here we would just call some xy point that is on the circle. So that's our diagram for our circles. Now our information that goes with this, so on the bottom side of that flap, you're going to put down the center, and our center is at h comma k, and then the radius is r. One thing to keep in mind, just like we did with the parabolas, we use the opposite of both h and k. Alright, here's our first practice set. It says identify all the key features of the circle with the given equations. Now if you look at the important information we just wrote down, we only have two key features of circles. One of them is the center, and the other one is the radius. So what we need to do is find the center. I'm going to go ahead and do this first one here with you, and then I'm going to have you pause the video to try the second one. So as I look at my equation, it says I have x minus h, that quantity squared, plus y minus k squared is equal to r squared. So what I need to look at is figure out what's my h, what's my k, and what's my r. Now in this situation, I don't have any value being added or subtracted from my x, so that indicates that my h is a 0. Over here I've got a plus 9, but remember you have to take the opposite of it, so my k is a negative 9. And this part right here, the r squared is equal to 10. Well, we need just r, so we have to set up the equation r squared is equal to 10, and then to get rid of the square we need to square root both sides. And we end up with r is the square root of 10. Now the reason we don't have plus minus on this, even though we applied the square root, is because this is a distance and we aren't going to be dealing with negative distances. So our key features would be our radius is the square root of 10, and our center is at hk, which would be 0 comma negative 9. Okay, on the second one I'll give you a little bit of a hint. You have got to get rid of these 2's out in front because our formula has no value in front of here. So think about how you're going to get rid of those 2 2's right there, and then go ahead and pause the video and try this one and see what you come up with. Okay, this problem I did in the blue, and in order to get rid of those 2's, I need to divide everything by 2. Remember that an equal sign is kind of like a balance scale, so whatever I do to one side of my equation, I have to do the exact same thing to the other side of my equation. When I divided everything by 2, those 2's that were causing me a little bit of a problem canceled each other out, and then 40 divided by 2 gave me a 20. Then I went ahead and I found my h to be negative 3 because I need the opposite, my k to be a positive 5, and then r squared is equal to 20. So I square rooted both sides, and I got r is equal to the square root of 20, which you could write as 2 square roots of 5, or if you need the decimal of it, you would write it as about 4.47. So my radius, either of these values right here, and then my center, when I do my h comma k, it's negative 3, 5. One thing to make sure you pay attention to is that the h value is always with your x variable and the k value is always with your y variable. Even if these had been written in reverse order and the y's were first and the x's were second, you've got to make sure that you pay attention to that because that will happen once in a while. Okay, here is the second one. Go ahead and pause the video and see if you can use the information given here and the fact that you have a formula for your circle and see if you can write the equation for that circle. Okay, if you're having a little bit of trouble, think about this is the center, so this is our h comma k, and a point on the circle. So this is just one of those points like we had on our picture, this xy point. So I've given you an x and a y here. What you're going to need to do is you're going to need to use that information to figure out what your r is, because when you write the equation of the circle, you should have numbers only in the places of h, k, and r. The x and the y should remain an x and y variable. So go ahead and give it another shot to see if that helps you out at all. Alright, on this one I did it two different ways. In the blue, I used just the equation from my flip book, and then I plugged in the values I knew. I knew that x was 10, I knew that h was 6, but I had to use the opposite, so it's minus 6. Then I squared that, added my y was a 20, my k was 8, so I needed the opposite, so I had to subtract 8, and then filled that out. So my 10 minus 6 gave me a 4, 4 squared is 16. 20 minus 8 gave me a 12, 12 squared is 144. Solve that out and I got r squared to be equal to 160. And now I stopped there because in my formula I need r squared. So I just went ahead and plugged in the 160. And then when I write my equation, x will always remain an x. The h will be a number, y will always remain a y, and the k will be a number. So I got my equation that way. Now over here in the red, I decided I was going to use the distance formula because when I started with my equation, I had h, I had k, but I was missing an r. Well, I know from this picture here that r is the distance from the center to that point on the circle. So I went ahead and used my distance formula, which took me down to the fact that r is equal to the square root of 160. So then I plugged in all this information I knew, and I had the x minus 6 quantity squared plus y minus 8 quantity squared is equal to the square root of 160 squared. Now the reason I have that is because in my formula it says r squared, and I figured out that r was the square root of 160. Well, then I had to make sure I squared that. And when I did, I get the exact same answer. So you have to decide which way works best for you, because both of them will give you the same answer every single time. It's up to you what you choose. Alright, and our last one that we need to look at is what do we do when we need to graph these? Well, when we need to graph things, we need to find our two key points. We need to find our center and our radius. And for this one, we have x minus h, quantity squared, plus y minus k, quantity squared, so it's in the right order, and that's equal to r squared. So my center is always at hk, but remember I need to take the opposite, so instead of a positive 2, it's a negative 2. And my k, instead of being a negative 3, is a positive 3. So my center is going to be at negative 2, 3. Then my radius. Remember, according to our formula, it's r squared is equal to 6, so I need to square root both sides. And I get r is equal to the square root of 6. Now when we're graphing this, I need the decimal approximation. And when you type the square root of 6 into your calculator, you get about 2.44-ish. So we're going to call the radius the square root of 6, which is approximately 2.44. Now when I go to graph this, I'm going to start by plotting my center point, and then I'm just going to use counting in order to get 4 more points on my circle. Then I'm just going to sketch it in. So I'm going to start by going back 2 and up 3. That is the center of my circle. Now realize that's not actually part of my circle, because the circle is actually only the points that are equal distance from that, but we need this as a reference point. Now I'm going to use the fact that my radius is 2.44. And that tells me that from my center, I need to go 2.44 in all directions. Now there's an easy way and a hard way to do this. The hard way would be to use the distance formula and try to go diagonally and figure out where those points are. But if we go straight along our graph paper, we can do just basic counting. So if I go to the right 2.4-ish, that puts me right about there. So there's 1 point on my circle. Then I go back to my center, and I need to go up 2.4. There's another point on my circle. Then I need to go back to the center, and I need to go to the left 2.4. Then I need to go down 2.4. And now I've got 4 points that are on my circle, and I'm going to connect them using a smooth curve. This is probably the hardest part because it's really hard to not make this look like a diamond. But what you want to do is you want to do a smooth curve, oh that's horrible, through all of those points. And then there you would have your graph of your circle that has a radius of 2.44.